All right, well, we're looking at this concept of indirect proof, or proof by contradiction, or proof by negation. And we're given a couple of algebraic proofs to consider using this method of indirect proof. So let's take a look at what we have here. This corresponds over here. This is from example 2 on page 356 in your textbook. So we're given a statement here that if 7x is greater than 56, then x is greater than 8. So our hypothesis, our given, is that 7x is greater than 8. We're trying to prove that x is greater than 8. But we're going to do that by using indirect proof. Now, indirect proof means that we will take this statement and make it make the assumption and contradict it. And so by doing so, we would then say that by indirect proof, x is less than or equal to 8. That would be the opposite of x is greater than 8. Now, since we're doing this algebraically, we're going to put together a table of values and see what we come up with. So let's say that when x is 5, now that is less than or equal to 8, right? 5 is less than 8. We're working on this indirect proof. Well, then 7x, well, 7 times 5 would be 35. But 35 is not greater than 56. It's less than 56. How about when x is 6? That's less than 8. So 7 times 6 is 42. Well, 42 is not greater than 56. It's less than 56. So let's see, how about when x is 7? Well, 7 times 7 is 49. Again, less than 56. And how about when x is equal to 8? Well, 7 times 8 is 56. And that's equal to 56, but that's certainly not greater than 56. And so what we have done is we have proven that our indirect proof is in fact false, which then is going to mean that the original conclusion is in fact true. X must be greater than 8 because we have proven that x, when x is less than or equal to 8, then 7x is not greater than 56. So let's see what we got. So when x is less than 8, 7x is less than 56, and when x is equal to 8, 7x is equal to 56, but that's different than what our condition is, which is 7x is greater than 56. So therefore, if we're writing this in a proof, we might say it like this. In both cases, x being less than 8, or in the second case, x being equal to 8, the assumption leads to a contradiction to 7x is greater than 56. In other words, so when x is less than 8 or equal to 8, that doesn't give us a true statement of 7x is greater than 56, and we see that right there. Therefore, the assumption that x is less than or equal to 8 is false, so the original conclusion, x is greater than 8, must be true. This is an example of using indirect proof. We take the conclusion, this is the conclusion, we state it in an opposite manner, set out to prove or verify that, and when this becomes false, then that would conclude us to believe that this is the original statement is in fact true. Let's look at one other right quick. We'll try to do it quickly. Okay, so here we got if negative c is positive, then C is negative. Negative C is positive. So negative 1 times C, if that's positive, then C must be negative. Makes sense, negative and a negative has got to be a positive. Okay, so here we go. We're given that negative C is greater than 0, positive. Prove that C is less than 0. Now that would cause us to write our indirect proof. We're writing something opposite to this as the indirect proof that x is greater than or equal to 0. So again, we got some table of values here. And so let's say that let's say that C is 0. Well, if that's the case, obviously then negative 0 is just 0. What about when C is 1? All right, that's greater than or equal to 0. That's our indirect proof. Well, then negative C would be negative 1. And that's not positive. That's a negative number. How about when C is 2? Well, when C is 2, negative C is going to be negative 2. And how about when C is 3? Well, then, of course, that's going to give us negative 3. All right, so let's get busy about going about formulating our proof. So if C is greater than 0, then negative C is less than 0. And if C is greater than 0, this is what we see right in here. C is greater than 0 or equal to 0, then negative C is less than 0. And if C is equal to 0, then negative C is in fact 0. So, again, in both cases, the assumption, now, where's the assumption? This is the assumption. The indirect proof is what we're calling the assumption of the given information that C is greater than 0. Therefore, the assumption that C is greater than 0 must be false. That's in contradiction to if negative, then C must be negative. Well, here we see nothing but positive C's, but it is not giving us positive numbers. And the original conclusion that C is less than 0 must in fact be true. All right, writing an indirect proof. Don't you love proofs? Don't answer that question.